Hello everyone, I am Shankha Subra Sanyal and I welcome you all on behalf of S-Cube's classes. Well, I'm really thankful to all of you for your overwhelming response. The amount of love that you have shown through your mails, through your feedbacks, I'm really grateful. I'm really privileged. Well, this is the second lecture of the series on number systems. As I have discussed that number system happens to be the lifeblood of mathematics, because if you don't understand number system clearly, it will become very difficult for you to sail through with maths. In the previous lecture, we had already discussed about the various types of numbers and how they may be represented on the number line. This is the second of the series, and here we'll be talking about how decimal numbers are represented. Here we also will be talking about terminating decimals, we'll be talking about non-terminating decimals, and so. Let's begin the session. Every rational number p by q can be expressed as a decimal. On dividing p by q, two possibilities arise. What are these two? Number one, the remainder becomes 0 and the division concludes after a finite number of steps. In this case, the decimal expansion obtained also terminates or ends. What could be the second possibility? The remainder never becomes 0 and a repeating string of remainders is obtained. In this case, we get a digit or a block of digits repeating in the decimal expansion. Thus, we have two different types of decimal expressions. Number one is terminating and number two is recurring. Let us see what are these one by one. A decimal that ends after a finite number of digits is called a terminating decimal. For example, 1 by 4. After doing the calculations, we find that it becomes 0.25 and the remainder is 0. Same is the case with 5 by 8 or maybe 2 full 3 by 5. If I keep it in a mixed fraction, that will come down to 13 by 5 and it will be yielding me a result 2.6. In each of the cases, the remainder is 0. Thus, each of the numbers 1 by 4, 5 by 8 and 2, 3 by 5 can be expressed as a terminating decimal. There's an important rule to this. A rational number p by q is expressible as a terminating decimal only when prime factors of q are 2 and 5 only. For example, each one of the numbers 1 by 2 or 3 by 4, 7 by 20 is a terminating decimal since the denominator of each has no prime factors other than 2 and 5. Well, what I actually meant, let us understand that with an example. Without actual division, let us find which of the following rational numbers 5 by 32, 11 by 24 and 27 by 80 are terminating decimals. In 5 by 32, the denominator is 32. So what is 32 basically? 32 can be represented as 2 raised to the power 5. Now 32 has no prime factors other than 2. And as I said that a terminating decimal can have only prime factors 2 and 5, nothing apart from that. So 5 by 32 happens to be a terminating decimal. Let us move to the next case, 11 by 24. If you see 11 by 24, 24 is the denominator. It can be represented as 2 raised to the power 3 into 3. Check over here, you have 3 which is a prime factor, which is anything other than 2 by 5. Thus, just by looking at the denominator, I can predict that 11 by 2 is not going to be a terminating decimal. While if I come to the third one, which is 27 by 80, I find that the denominator is 80 over here. That means it can be represented by 16 into 5 or simply 2 raised to the power 4 into 5. So the prime factors over here are 2 and 5 only. There is no other prime factors. So 27 by 80, just looking at the number, I know that it is a terminating decimal. Let us see what are repeating or recurring decimals. Well, the word recurring comes from the word reoccurring. A decimal in which a digit or a set of digits is repeated periodically is called a repeating or a recurring decimal. In a recurring decimal, we place a bar over the first block of repeating digits and omit the other repeating blocks. Suppose we have 2 by 3. So what is 2 by 3? On a division, we find that it is 0.66666. It goes on. So we just put, since 6 is getting repeated again and again, I put it as 0.6 and a bar over 6 as 6 is repeated. But if I get another number 3 by 11, which on division yields me 0.27, 27 and 27 dot dot dot, then since 27 is the block which gets repeated, I would put it as 0.27 bar. Similarly, if I have 15 by 7, which yields me the result 2.142857142857, we see the factor 142,857, that is this block of number is getting repeated again and again. So what I am going to do, I'm basically going to put a bar on that. Another example that is given on the screen is 11 by 6, which is 1.83333. Now check over here, 8 is not getting repeated, but what is getting repeated? It's 3. So I put a bar on 3, not on the entire thing. So how can I represent 11 by 6? I can represent that as 1.83, a bar over that. Well, you must have noticed that a string of remainders in each of the cases that we have discussed goes on repeating. Like the first case, it is 2, 2, 2 and so on. In the second case, it is 8, 3, 8, 3, likewise. So we must note that the number of entries in the repeating string of remainders is always less than the divisor. In 2 by 3, only one number 2 repeats itself and the divisor is 3. In 5 by 7, a set of 6 digits, namely 132645, repeats itself and the divisor is 7. Thus, if the divisor is n, then the maximum number of entries in the repeating block of digits in the decimal expansion of 1 by n is n minus 1. So what is a length of a period? The repeated number of decimal places in a rational number is called the length of the period. Like the example that we are discussing, 15 by 7 is nothing but 2.142857. See, there is a bar over that. Check what is the divisor? It's 7. So we have maximum 6. This is known as the length of the period. Let us now discuss some spatial characteristics of rational numbers. The first one is every rational number is expressible either as a terminating decimal or as a non-terminating recurring decimal. And what is the second one? A number whose decimal expansion is terminating or non-terminating recurring is rational. Let us take an example and express 3 1 by 8 in the decimal form. What we have, 3 1 by 8 is nothing but 25 by 8. If I divide that by the actual division method, what we come across 3.125 as the answer. But if we have another example, 2 by 11, and we are intending to find the decimal form of this, we would get 0.181818 getting repeated by the actual division method. So we can represent 2 by 11 as 0.18 bar. If I'm asked to write 3 by 13 in decimal form, and say what kind of a decimal representation it has, let's see how to do it. By the way, this question came in 2010 board exams. Well, by the actual division method, what we have? We have 3 by 13 is nothing but 0.2307692, right? So we see that 0.2307669, this is getting repeated. So I can put a bar on this. So clearly 3 by 13 has a non-terminating recurring decimal representation. If I'm asked to find the decimal expansion of 1 by 7 by the long division method, what we have? 1 by 7 is nothing but we have 0.1428571428. What do I find? That the number, the block of numbers 0.142857 is getting repeated again and again. So if I go through this, I would find that 2 by 7 can be represented as 2 into 1 by 7, or 3 by 7 as 3 into 1 by 7. If you check, these are the numbers that are there on your screen, goes on repeating till we reach 6 by 7, which can be represented as 6 into 1 by 7. Let us take this question. What can be the maximum number of digits to be in the repeating block of digits in the decimal expansion of 1 by 17? So if I go by the long division method, what do I find? If 1 is divided by 17, it's coming up as 0.0588235. Things are given on the screen, right? Actually, if we see, there is a block of 16 numbers which goes on repeating, and this is known as the length of the period. Actually, the maximum number of digits in the repeating block of digits in the decimal expansion of 1 by 17 is always less than 17, that is 16. If we are asked to express 0.3 bar in the form p by q, where p and q are integers and q not equal to 0. So how can we do that? Well, this question again came in 2014. So this is an important question. What we are going to do is, let us take x is equal to 0.3 bar. Then x can be represented as, since it's a bar, means that number has got repeated many number of times. We can write x is equal to 0.333 dot 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 dot. Since the repeating block has only one digit 3, let us multiply x by 10. So what do we get? We get 10x is equal to 3.33. Let us name this equation as number 2, while the first one is x equals to 0.33. And let us subtract 1 from 2. What do we get? We get 9x is equal to 3. So x is nothing but 3 by 9, or we can call it 1 by 3. That means 0.3 bar is nothing but 1 by 3 if I need to represent it in p by q form. Similarly, if I have 1.4 bar, so 4 bar means 4 is getting repeated. It is 1.444. Let me call this as x and give a equation number 1. Since 4 is the single digits which goes on repeating, I again here multiply with 10. So it becomes 10x is equal to 14.44. And then I subtract it. Subtract equation number 1 from 2. What do I get? 9x is equal to 13. So we can write x equals to 13 by 9, or simply 1/4 by 9. Thus 1.4 bar can be represented as 1/4 by 9. Is that understood? Well, if I'm asked to express 0.9999 dot 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 as a fraction, then x is nothing but 0.99. Since 9 is getting repeated, what I'll be doing? I'll be multiplying this by 10, like the previous question that we had done. And what I'm getting after subtraction? We are getting 9x is equal to 9. So x is nothing but 1. So 0.9999 dot 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 can be represented as 1. But if we have a question like x equals to 0.57 bar, if you see here, there are two digits which are being repeated. That means we have to multiply this by 100. So it becomes 100x is equal to 57.5757 dot dot dot. On subtraction, we get 99x is equal to 57, or simply I can write by cross multiplication 57 by 99 is equal to x, which actually means 99 by 33. In case we have three digits, a block of three digits being represented as with a bar, then we have to multiply this by 1000 as shown on the screen. In that case, 1000x is equal to 1.0011001 kind of a thing. So here on subtraction, we get 999x equals to 1, or 0.001 can be represented as 1 by 999. Suppose we have a question as given on the screen. Now, this is a little difficult. Let's understand it this way. 2.4178. Now, see, the bar is basically on 178. That means 4 is normal. It is not getting repeated, but the block of 178 is getting repeated every time. That means over here, first what I need to do, first I need to move remove 4 out of the decimal part. Then we have to multiply that with 1000. So what do I get? I get 1000x is equal to 2417.8787. Then I'll be getting on subtraction 999x is equal to 2415.4, or in the simplest form it is 1277 by 4995. So this brings us to the end of the lecture. Well, before I sign off, as I always do, I would request you, in case you have any queries, please do feel free to write to me at scubesclasses@gmail.com, or you can WhatsApp me on the numbers given on your screen. It would be a privilege on my part to be addressing your queries. Thank you so much.